Next Generation of Air Traffic Management by Nick Lanham. What do you as an airline passenger think when someone says airport? Do you think long security lines? What about when someone says air traffic control? Do you think of a control tower? A control tower is only a fraction of what goes on with air traffic control, or ATC. Within a large control tower lie a series of dark rooms with the most important controllers are stationed. These controllers are called TRACON controllers. TRACON stands for Terminal Radar Approach Control. These controllers control aircraft that have just taken off and aircraft that are about 150 to 20 miles from their destination as they descend through lower altitudes from their cruising altitude. These two times are considered the most dangerous times to fly because there are high volumes of aircraft within a small amount of airspace, with aircraft that are going at different speeds. With having so many aircraft in a somewhat small amount of space, there is a higher chance for mid-air collisions and for more delays as aircraft try to bottleneck their way into busy airports. A way to alleviate from the extensive delays, some say, is to create a whole new way of controlling aircraft and controlling the aircraft's flow into the airports. This new system is called NextGen. NextGen has many benefits. Some of the benefits include more direct flights, which mean lower fuel consumption, lower fuel costs, and in turn, lower airline ticket prices. Another benefit is safer skies, because there will be a new component to airplanes that us, as airline travelers, won't even notice. This technology is called Automatic Dependent Surveillance Broadcast, or ADSB. ADSB is a system that will let air traffic controllers track aircraft via satellites in space rather than ground-based radar alone. Radar is becoming less and less reliable, which is why there is a need for ADSB. ADSB is a very important component to NextGen because it is what the whole new system is based on. NextGen works with a total of 3 components. These 3 components include a receiver in the cockpit of the airplane, a ground-based radar tower, and a satellite in space. So with ADSB, the aircraft have a connection with a satellite in space, a ground-based receiver, and the biggest change of all is that they have a connection with other aircraft that are near them so that they can see them via a monitor in the cockpit. About 97% right now of the aircraft airborne are being controlled via radar. Radar is becoming outdated and more unreliable, and its coverage is spotty. What I mean by that is that in most of Alaska, the Gulf of Mexico, almost everywhere below 700 feet, over all the oceans, and if within mountains or other types of interference, there is no radar coverage available. So to solve that problem, the FAA has created NextGen. The FAA has already implemented some ADSB in the Gulf of Mexico, parts of Alaska, and at the Embry-Riddle Flight School in Daytona Beach, Florida, they have equipped some of their aircraft with ADSB. For when they enter ADSB-equipped airspace, they could work with NextGen and traffic avoidance. Also, at Louisville, Kentucky's Standiford International Airport, ADSB has been set up to work with the high volumes of UPS cargo aircraft. The aircraft that are owned by Embry-Riddle are based in Daytona Beach, Florida, but the Daytona Beach airspace is not equipped with ADSB. So the aircraft equipped with ADSB are only using it for traffic avoidance and weather radar, whereas the UPS aircraft that are equipped with ADSB are flying using NextGen ATC. There's a lot more that goes into NextGen ATC, but it gets more complex and confusing. These things are the broad part of NextGen as compared to radar. Because NextGen is still in its infancy and won't be fully implemented until around 2018, some of the information given is subject to change. Thank you.